Okay, so let's start. So the other day we have started understanding the hypothesis testing, right? So what I said, hypothesis in general meaning is like a theory. Okay, so you claim something, fine, and then you need to perform certain tests. Based upon that, you can either accept or uh, you cannot accept the hypothesis. Okay, fine. So yeah, so as you can see, the hypothesis statement, assumption or claim about the value of a parameter. Okay, some value or some measurement. Okay, in anything in general life also you can apply. But here coming to specifically to you know statistics. So I think we also discussed what is simple and composite. Okay, so if the hypothesis is pointing to a specific value, okay, then it is a simple. Okay, or if it is just saying greater than 20, but how much it can be greater than 20, either it is 30 or 40, if there is no any specific measurement, then it is a composite hypothesis. Okay, so I hope you got a general idea about hypothesis. Okay, now let's go into the actual concept. Okay, see guys, in statistics, okay, in statistics, in the hypothesis testing, mainly you have two things. One is null hypothesis, other thing is a alternate hypothesis. These are extremely important. See, what is null hypothesis? See, the idea is a bit different. Okay, so let's try to focus here. As I said, hypothesis testing is simply you can make some hypothesis. Okay, that's fine. But here we will create two hypotheses. One is null and one is alternate. Okay, so in simple words, I'll tell you, null hypothesis and alternate hypothesis will always be opposite to each other, guys. Okay, they'll always be opposite to each other. And who are going to create this? You are going to create this based whatever you want to prove or whatever you want to claim. Based upon that, you need to formulate this null hypothesis and also alternate hypothesis. Okay, so let's say, for example, you will say you are saying the mean of the population is let's say 50. Okay, so null will say mean equal to 50. Alternate will say mean is not equal to 50. Okay, so the way how you create these two hypotheses are, these both will be disagreeing to each other. Why we are doing that way? Why we are doing intentionally that way? Because at the end of the day, any one of these should be true, not the both. Okay, either of this must be true. Both cannot be true. Okay, so means obviously, right? So if a population is there, okay, its mean will be something, whether it will be 50 or it's not, it will not be equal to 50. Okay, so but you don't know, so that's why what you will say, you will take null hypothesis as 50 and you will do some test. Okay, and you will do some test. Okay, and at the end of the test, if you are able to collect some evidence proving, okay, or supporting that this mean equal to 50, what you will do, you will say, okay, whatever the null hypothesis is saying, that is true. You will accept the null hypothesis. Agree? You will accept the null hypothesis. But if you're not able to collect this evidence to prove that mean equal to 50, what you will do? You will accept the you cannot accept the null hypothesis. You will reject the null hypothesis so that it will automatically accept the alternate hypothesis. Getting? So in either you will accept null hypothesis and reject alternate, or you will reject null hypothesis and accept alternate hypothesis. Okay, so this will happen automatically. How it will happen? The way how you create null and alternate hypothesis will be in such a way that if one is true, automatically the other will be false, and if one is false, automatically the other will be true. Okay, see, let's try to understand here more. Okay, so don't worry. So as I said, these are like some intuitional concepts, so slowly you will get it. Okay, these are not like some technical concepts, so directly you cannot write a formula and understand. So you need some intuition to understand. So we'll try to understand. See, null hypothesis. In simple terms, a null hypothesis is a statement that assumes that there is no significant effect or relationship between the variables being studied. Okay, this happens. So see, null hypothesis is H naught, right? So null hypothesis is also generated by H naught. So H naught, the way how null hypothesis will create is mostly we will say there is no relationship between the variables being studied, or there is no significant effect. So null hypothesis will always be like that, like nothing interesting is happening. Everything is normal. Okay. So that is how we create the null hypothesis. Okay. That means, for example, let's say you want two variables, guys. See, try to understand there are variable 1 and variable 2. Okay. So forgetting about all this, if these are two variables, and if you want to find out if there is a relationship is existing between these two or not, what are the possible cases, guys? One, there is relationship. One, there is relationship. Two, there is no relationship. Agree? Agree, guys? If there should be some relation, there should not be some relation. Given two variables. Now, I don't know. I don't know which one is correct. So obviously you need to do, you have these two. So you have something called as null hypothesis, okay, and something called as alternate hypothesis. As I said, both of these will be opposite to each other, means one will contradict the other. Okay. If null says relationship is existing, alternate will say no, relationship is not existing. Why we are taking like that? So that finally, after doing some test, okay, after doing some test, if you prove one of these, automatically the other will get disproved. Okay. See, that means, for example, if this is simply, I'm saying, if this is less than 5, okay, this will be obviously greater than 5, greater than or equal to 5. Agree? So whatever this is not covering, this will cover. But it cannot be like if this is equal to 5. Okay. See, try to understand. So if, see, 1 second, I'll tell you. See, guys, if in simple example, if null is saying less than 5, if alternate is saying greater than or equal to 5, okay, and if I get a value 10, okay, if the value is 10, which one should I accept?
Alternate hypothesis.
Okay. 20,
Alternate.
6,
Alternate only.
3,
Null hypothesis.
1,
Null hypothesis.
5.
Alternate.
Okay. So you cannot find a situation where you will accept both or reject both. Can you tell me can you give me any number where you will accept both? No, right? No. Okay. So, but if I say instead of greater than 5 and less than or equal to 5, okay. But if I say null hypothesis is equal to 5, this is less than or equal to 5. Okay. So in this scenario, if I give 10, okay, so it is not covering, fine. If I give 4, it will be alternate. But if I say 5, it can be null or it can be alternate, because this is also equal to 5, this is also less than or equal to 5. Getting? If at all we frame this way, that means if this is equal to 5, this is less than or equal to 5, but when the value is actually 5, you cannot choose any one of this, because this is also having equal to 5, this is also equal to 5. Fine. So that's the reason we will not choose it this way. The point is, we will choose null and alternate in such a way that only one of those will be true and other will be automatically false. In other words, what all scenarios null is not covering, alternate would cover. That means if it is saying there is some relationship, null will say there is no relationship at all. That means there is no relationship, this will say. Finally, when you do some test and if you are convinced, okay, there is some relationship, that means you are accepting null. which means you are automatically rejecting alternate. Okay, or from your test you did not see any relationship, then what you will do? You cannot accept this, you will reject this null. You will reject this null. That means there is no really whatever. Sorry. Null is saying what? Null is saying, hey, there is some relationship. But after the test, you cannot see any relation. So what you will say, hey, null, whatever you are saying, I cannot accept that because I don't see it from my testing. So I cannot accept you. So you will reject this. Fine. So when you reject this, what does that mean? Automatically you are accepting the alternate. That means alternate is saying there is some relationship. Okay. Are you getting this? Or is it confusing?
No, Santosh, it's fine.
Okay. So similarly, if you are having null and alternate, okay. So let's say if I want to find out if the two variables, if there is any relation, any sort of relation, correlation or any relation, okay. So there are two cases, right? So one, there will be relation, and one, there will not be any relation. Okay. So statistically, every time null hypothesis we will take, and it's a general, okay, scenario that null will always assume like there is no significant effect or relationship between the values being studied. That means it will say, hey, there is no relationship between these two variables. Okay, that type of options it will choose. Okay, by default null will be taking, or while we are considering also, we will take the scenario, okay, the least important, okay, or nothing interesting is happening, or there is no significant effect can be observed. Okay, so that option will be given to the null hypothesis. Okay, because why? If we reject this, we will accept this. Okay, that means what? We are going to come and accept, and what will null alternate hypothesis will say? Hey, there is some relationship existing. Okay, so there are two variables. Goal is to see if there is a relationship or not. I don't know, so I'll say null is saying, null statement is saying, I think there is no relationship between these two guys. Alternate is saying there is some relationship. Okay, so these are two hypotheses. These are just hypotheses, guys. As of now, we don't know which one is true. Null can be true, alternate could be wrong, or null could be wrong, alternate could be true. Are we good till this point?
Yes.
Yes, sir.
Okay, fine. So once we do this, we'll do some test. Okay, we have formulated. Okay, we have formulated this. Okay, now then we will perform some test. We'll perform some test, and from the test, okay, and from the test and some values, okay, some correlation values we know, or some visualizations we'll do, and we understand something. Okay, for example, let's say first thing is we understood there is some relationship between. Okay, so the way how we do here is we focus on the null hypothesis. Okay, see, formulation is done. Then we'll take this null hypothesis, whatever null hypothesis is saying. Okay, so we do some test. Okay, and the point here is we will try to either accept the null hypothesis or reject the null hypothesis, guys. Okay, so try to understand. So we will try to either accept the null hypothesis or reject the null hypothesis. We don't directly work on alternate hypothesis most of the time, because if we work on null hypothesis, indirectly we are already working on alternate hypothesis. Agree? So that's the reason why guys, why I'm making that statement, because from the test, if I accept null hypothesis, what does that mean? I'm rejecting alternate hypothesis automatically, correct? But if I reject null hypothesis, that means I'm accepting alternate hypothesis automatically, because one of those statements should be true. Agree? One of these should be automatically true. That means I did some correlation test, okay, and I got correlation value is, let's say, what was the correlation coefficient value? It will range from -1 to 1. -1 to 1 is the correlation value, right? And if it is 0, there is no correlation. Okay, if it is 0, then there is no correlation. Fine, you remember? So -1 to 1 Pearson correlation coefficient. So if it is 0, there is no correlation. Fine. So what is null saying? Null is saying there is no relation. That means correlation is 0, it is saying indirectly. Okay, but alternate is saying no, there is some relation. That means it could be greater than 0 or it could be less than 0. That means positive or negative. Doesn't matter, but there is some correlation. The alternate is saying. So I have done some tests. Okay, so if the test value, correlation value is exactly 0, what does that mean? That means there is no correlation. So now whatever the null is saying that there is no relation bit, that is true because the value from the test also I got 0. So in that case, what I will do? I will simply accept the null hypothesis. There is no chance. There is no choice for me. I need to just simply accept the null hypothesis, whatever it is saying. Agree? So the moment when I'm accepting null hypothesis, okay, the moment when I'm accepting null hypothesis, I am rejecting the alternate because what is alternate is saying? Alternate is saying there is some relation. But since I accept null hypothesis, which is stating that there is no relation, obviously I am rejecting this null hypothesis. So accepting null hypothesis will automatically reject the reject the alternate hypothesis. Okay, but if you find some value, either it is some 0.9 or minus 0.5, anything, that means and there is some correlation. Okay, in that scenario, whatever null is saying, that is wrong because null is saying there is no correlation, but clearly I can say some positive or negative correlation. Okay, so I will reject null hypothesis here. I will reject null hypothesis, which automatically means I am accepting the alternate hypothesis. See here, alternate hypothesis is saying there is some relation, so that is true. So how I am getting? So I am able to reject null hypothesis. So I am accepting null hypothesis. I am accepting the alternate hypothesis. Getting guys? Honestly getting?
Yes, Santosh.
Okay, but one important guys, see, I'll show you example, don't worry, but one important guys, try to understand that we will not work on the alternate hypothesis guys directly. Null hypothesis only we will take, and our focus is just accept it, reject it, that's all. Okay, if you accept it, automatically you are rejecting the other one, or if you reject it, automatically you are accepting the other one. Okay, that will happen automatically, but our job is mostly focus on null hypothesis and just try to see whether we can accept it, collect sufficient evidence, whatever the null hypothesis is saying. If you find sufficient evidence, then you will accept it, or if you cannot, you will reject it. Okay, okay, fine. So fine, let's try to go a little deeper. So now see, in simple terms, the null hypothesis will always state that there is no significant effect or relationship. It serves as a starting point for the hypothesis, okay, and represent the status quo or the assumption of no effect until the proven otherwise. Okay, the purpose of hypothesis testing is to gather evidence to either reject or fail to reject the null hypothesis in favor of alternate hypothesis, okay, which claims there is significant effect of the relationship. Okay, so what is the purpose of hypothesis testing? We will gather evidence, okay, to either reject the null hypothesis or fail to reject the null hypothesis. Okay, fail to reject the null hypothesis. Okay, fine. So now what is alternate hypothesis? The alternate hypothesis is a statement that contradicts the null hypothesis and claims there is significant effect or relationship between the variables being studied. Okay, this is just the opposite, contradicts the null hypothesis, and it will say when a null is saying there is no so there is no significant effect, it will say there is significant effect, okay, between the variables. It represents a research hypothesis or the claim that the research wants to support through statistical analysis. Okay, that is fine. But now see, there is very one tricky point over here. Okay, see, failing to reject, okay, failing to reject, okay, does not mean the null hypothesis is true. What does that mean? What does that mean? See, if null hypothesis, see, let's try to understand. Null is saying something, okay? If you accept it, okay, if you accept it, whatever it is saying, that's one thing. But if you are failing to reject it, okay, if you are failing to reject it, that does not mean, that means I want to reject it. How can I reject it? I want to collect sufficient evidence. Okay, I want to collect sufficient evidence so that I will say, oh, because of this evidence from this data, I'm rejecting you. Okay, if I do that, that's fine. But But see, if I fail to reject null hypothesis, that does not mean null is true. Okay, so this statement will focus a bit more. See, whatever the null is saying, if I fail to reject, I did not collect sufficient evidence. Okay, so I have failed to reject. But simply if I fail to reject, that does not mean null is true. Okay, that only means that I am not able to collect sufficient evidence to reject the null. Just because I am not able to reject the null, that does not mean that is true. Okay, I'll give an example so that you will understand this better. Okay, don't get confused. See, what happens? See, let's say, see, one way to think about the logical hypothesis is by comparing it to the US court system. In a jury trial, jurors are told to assume that defendant is innocent until proven guilty. Okay, innocent is a default assumption. See, this is a perfect example. Whenever someone is acquitted, okay, not acquitted, so whenever someone is accused, okay, in some case, let's say a trial is going on. Okay, see, let's say trial is going on. Okay, let's say this guy is a judge, okay, and this guy is a accused. Fine. So you will have his defending lawyer, you will have his lawyer. Okay, this guy is a judge, this guy is accused. Okay, and this guy is, that means criminal, not because see, I cannot call him criminal because the trial is still going on. Okay, it's not proved. Okay, so if it is proved, he will be in the jail. As long as it is not proved, the trial will continue. Getting? And this guy is a lawyer. Okay, this guy is a lawyer. Okay, he's against this guy. Okay, he's against this guy. Okay, so what happens? This guy will say, I did not do that crime. Okay, obviously the person will say, sir, I don't have any relationship with that crime. I did not do that crime. Okay, but this guy will argue, no, you have done the crime. Okay, see, what is this guy's statement? This guy's statement is, I am innocent. I did not do any crime. Getting, guys? This scenario, did you understand? Courtroom scenario.
Yeah, Santosh.
Okay, judge and the person, accused person. Okay, accused means what? Muddai. Okay, we did not prove that he is already a criminal. Okay, still we are checking him, verifying whether he has done that crime or not. And this guy is a lawyer, opponent lawyer. Now this guy is saying, sir, I am innocent. That is null hypothesis. Okay, that is null hypothesis. What is alternate hypothesis? No, he is not innocent. He is guilty. Guilty means he has done that crime. Okay, guilty means he has committed that crime. These two are the statements. Null is saying, I am innocent. Guilty is saying, he is not innocent. Okay, so in a jury, that means during the trial, so they will assume this, innocent until proven guilty. Okay, he is innocent only when till he is proven guilty. That means what? I don't know whether, let's say I am judge. Okay, so what I will think, I will go by this innocent until proven guilty line. That means whoever is standing in that accused place, I don't know whether he has done that crime or not. Okay, so as long as I don't have, okay, as long as this opponent layer don't submit the required evidence to me, I cannot charge him. I cannot give him any type of punishment. Agree? So that means what? I will consider him as innocent until proven guilty. Okay, as long as he is proven guilty, okay, I will consider him as innocent. Okay, but here point here is let's say on first time, okay, on first time, in the first trial, this guy, this opponent lawyer has come to the court and he argued, okay, and he has submitted some evidence, okay, and he has submitted some evidence to the judge saying that this guy has actually committed the crime. Okay, this guy has actually committed the crime. Okay, so but the judge felt that evidence is not enough. Okay, the evidence is not perfect, or there are some mistakes in the evidence. Okay, so the judge understood that I cannot accept this evidence. This evidence is not sufficient for decide that, or to give a statement that this guy has committed the crime. So now what happened? Null hypothesis is innocent. Okay, null hypothesis is innocent. I want to reject this null hypothesis. Agree? Getting, guys? To prove this guy is not innocent, what I should do? I want to reject this null hypothesis. Fine. If null is saying innocent, okay, I want to disprove this. I want to reject this. That means reject the null hypothesis. Okay, reject the null hypothesis. If I reject this, then which means this is wrong. The defendant is innocent is wrong. Okay, that is my goal. But if I am not able to collect sufficient evidence, okay, or okay, whatever the evidence I have submitted, the judge is not convinced. Fine. So I have failed to reject the null hypothesis. Correct? I have failed in rejecting the null hypothesis. Okay. I have failed to reject the null hypothesis. But that does not mean, see, this is a point. Failing to reject the null hypothesis, that means here when I don't have sufficient evidence, I have failed to reject the null hypothesis. Failing to reject null hypothesis, that does not mean null hypothesis is true. That means if I just fail, if the lawyer, as a lawyer, okay, if I am not able to submit sufficient evidence, guys, so obviously the judge will not accept it. Okay, so I did not have a chance to reject this guy. Reject this null hypothesis. Okay, so but just because I did not reject this, okay, I did not reject this null hypothesis, it does not mean that this is true. Okay, I cannot say he is innocent. It only means that at this point of time, I am not able to collect sufficient evidence. Maybe after a week, after a month, I might get sufficient evidence so that I can reject you. So as of now, I have accepted the null hypothesis. Okay, I have rejected the null hypothesis. See, there will be two scenarios. Okay, whether you are rejecting the null hypothesis or you have failed to reject the null hypothesis. Okay, you have failed to reject the null hypothesis. Fine. So usually we do this. Okay, so you might think one is accepting null or rejecting null. That is one point. Okay, but here the scenario is one is if you are perfectly providing the from your test. Okay, what is this guy submitting some evidence, and in our statistical case, what is that? We will do some test, correlation test, this test, that test. Okay, and if you are able to get some measurements or parameters with that perfectly, if you are able to reject this guy, then it's fine. Okay, then it's fine. It's called clear rejection of the null hypothesis. Okay, and obviously in this case, where you will go to alternate hypothesis only. Okay, alternate hypothesis only. Now, but in other scenario, in some other scenario, if at all you did not collect the sufficient evidence, okay, then what you will do? You have failed to reject this guy. Okay, you have failed to reject this guy. Okay, but that does not mean this statement is true. I just failed to reject. Okay, just because I have failed to see, a thief is running. Just to give an example, a thief is running. Okay, I'm also running to catch him. Okay, I did not catch him. Does that mean he's not thief? It only means that I failed to catch him. Just because I failed to catch a thief, that does not mean that he is innocent. Agree? Here also, just because I have failed to reject, okay, I did not find sufficient evidence, so I have failed to reject this null hypothesis. Okay, so just because I have failed to reject null hypothesis, that does not mean this null hypothesis is true. Okay, so in like in hypothesis testing, it is not the jury job to decide if the defendant is innocent. That should be their default assumption. They are only there to decide if the defendant is guilty. Okay, or if there is not enough evidence to override the default assumption. The burden of proof lies on the alternate hypothesis. Okay. See, by default, he will assume that the defendant is innocent. Okay, that's a null hypothesis. Okay, the judge will not decide whether he is innocent or not. Judge work is to decide whether he is guilty or not. Judge job is to decide whether he has done that crime or not. Okay, so but he will not say whether he is innocent or not. By default, the null hypothesis is innocent. Okay, that is default assumption. Okay, but based upon the evidence what you are trying to get, okay, so whether you will reject this or you have failed to reject this. Okay, but just one point you need to understand here is, just because you fail to reject now, that does not mean it is always true. Okay, so in future, if you get sufficient evidence, more evidence, then you can come here and you can successfully reject this guy. Are you getting this?
Yes, sir.
Okay. Okay, fine. So we will see some example so that you will have a better understanding. Okay, see. First thing, yeah, so let me go there. So yeah, null hypothesis. The null hypothesis is a hypothesis to be tested or possible rejection under the assumption that is true. The concept of null is similar to innocent until proven guilty. We assume innocence until we have enough evidence to prove that the suspect is guilty. Okay, so first we'll assume he is innocent. Innocent in the sense what? He is that in statistical sense, that means there is no relationship is existing, or there is nothing interesting is happening, that there is no correlation, okay, or there is no this type of distribution, etc. So whatever you want to observe, okay, so null will say that is not happening, okay, and alternate will say that is happening. Okay, we will see it is denoted by h naught. Okay, the alternate hypothesis is a complement to null hypothesis. That means it is opposite of the null hypothesis, such that both alternate and null hypothesis together cover all the possible values of population. This is actually important. See, null is saying something, alternate is saying something. Okay, when you combine both, it should cover all the possibilities. Okay, so it is denoted by h1. Okay, so like now. Yeah. So as a soap company, if a soap company claims that it product kills on an average 99% of the germs, okay, Dettol will say it kills 99% of the germs. To test the claim of this company, we will formulate the null hypothesis like this. Okay, null will say average is 99. Alternate is saying average is not equal to 99. Okay. The thumb rule is that statement containing equality is a null hypothesis. Okay. See, there is a thumb rule that wherever you have the statement containing equality is null hypothesis. Okay, so here if it is there saying it is equal to average is 99, so null will say average is equal to 99. Alternate will say it is not equal to 99. Okay, these are two just hypotheses, guys. Suppose that we'll do some test, and from the test we will either accept this or reject this. That will happen. Okay, that will happen. But the way how you formulate, we need to understand. Okay, wherever you can equate some value, that will be given to the null hypothesis. Okay, so when we test a hypothesis, we assume that the null hypothesis to be true until there is sufficient evidence in the sample to prove it false. In that case, we reject the null hypothesis and support the alternate hypothesis. Okay, see, we do a test. While we are doing test, we assume null hypothesis is true. Okay, null hypothesis, whatever the null hypothesis is saying, we will assume it is true. Okay, but if there is sufficient evidence to prove that is false, we observe that, then we will reject the null hypothesis and support the alternate. Okay, if the sample fails to provide sufficient evidence for us to reject the null hypothesis, we cannot say that the null hypothesis is true, because it is just based on sample data. For saying the null hypothesis is true, we will have to study the whole population. Okay, see, you from a whole population, you took some sample data, and based on this sample data, you are doing some test. If this sample fails to provide the sufficient evidence for us to reject the null hypothesis, okay, based upon this data, you cannot you're not able to reject the null hypothesis. So obviously you should go and accept the alternate hypothesis. Okay, but in future, if you're able to get more amount of samples, okay, then you can come here and reject the null hypothesis based upon the data. Okay, so over here, so you are having, yeah, so there are one tailed and two tailed test actually. Okay, so what are one tailed and two tailed? See, if the alternate hypothesis gives an alternate in both direction less than or greater than of the value of the parameter specified in the null hypothesis, it's called two-tailed. Okay. If it is only one way, it is right. Okay. Simple guys, don't get confused. So one-tailed and two-tailed is, for example, see, if the null is saying 100, alternate is saying not equal to 100, that is one-tailed. Okay. That is one-tailed. Fine. So that means what? Null is saying equal to 100, alternate is saying not equal to 100. Simple. One-tailed. Why it is called one-tailed, we'll see with an example just within 2 minutes. Okay. Here, according to H1, mean can be greater than or less than equal to 100. Okay. But if at all, if you are having this in this scenario as according to H1, it is not equal to 100. Yeah. So here H1 is what? Alternate is saying what? It is not equal to 100. Okay. That means what? If it is not equal to 100 means it can be greater than or less than. Okay. See, if you're getting confused, I'll say this way. If null is saying equal to 100, alternate will say it is not equal to 100, then this is one-tailed test. One-tailed test. That means if you prove that it is not equal to 100, okay, if you prove that it is not equal to 100, okay, then it is one-tailed test. Okay. But if you have a scenario where you need to prove, okay, where you need to prove whether it is less than 100 or greater than 100. Okay. That means, for example, if null is saying not equal to 100, not equal to 100, if null is saying not equal to 100. So if it is not equal to 100, whether it is less than 100 or greater than 100, two tests you need to do. Okay. So in that case, it will be two-tailed test. In that case, in that scenario, it will be two-tailed test. Okay. So if you want to just prove a specific statement, that means not equal to, if it is a statement is equal to 100, if you just prove it is not equal to 100, then it is one-tailed test. Okay. Whatever it could be, less than 100, greater than 100, whatever it could be, but if you just prove that it is not equal to 100, then it is one-tailed test. Okay. But if the null is saying it is not equal to 100, okay, it is not equal to 100, okay, in that scenario, you need to prove whether it is less than 100 or it is greater than 100. Okay. That will be two-tailed test. Okay. With an example, we'll try to understand these things, guys, so that we'll have better understanding. Okay. Right. So before that, you will have something called as critical region, guys. Okay. Before that, you will have something called as critical region. Okay. Critical region is that region where you can reject the null hypothesis. Okay. So critical region is that region where you can reject the null hypothesis. Okay. So that means what? See, I'll give a simple idea. Okay. Critical region is where you can what? Reject the null hypothesis. Okay. For example, simply I'll give an example. Sorry, simple example I'll give you. My null hypothesis is I'm making a statement. My null hypothesis, I want to buy a laptop. I will buy a laptop. For example, I will buy laptop, and my budget is, sorry, I'll buy laptop and my budget is 40K. If it is less than or equal to, if the cost is less than or equal to 40K. Okay. So you have went to the market and the ranges are between 15K to 1 lakh. Okay. And my budget is 40K over here. Okay. So if my null hypothesis should be true, what is my null hypothesis, guys? I'll buy the laptop. That means if I buy the laptop, my null hypothesis is true. Do you agree, guys? Are you there with me?
Yes, sir.
Right. So in this region, wherever the laptop is costing in whichever shop the laptop is costing from 15,000 to 40,000, I will be able to afford it. I can buy it. I can spend that much amount of money, so I will buy it. Okay, I will buy. So here my null hypothesis is true. That means I will accept the null hypothesis. Accept the null hypothesis. Agree? Because null hypothesis is saying I will buy the laptop and I'm able to buy the laptop. But in this region, I cannot buy the laptop because I don't have that much money. 40,000 greater than 40 I don't have. So I cannot accept this. I will reject this. I'll reject null hypothesis. Getting why? Null is saying I will buy, but I'm not able to buy. So obviously I will reject null hypothesis. This area where you are rejecting the null hypothesis is called critical region. Is that clear?
Yes, sir.
Everybody, the area where you are able to reject the null hypothesis is called critical region. Simple. Okay, fine. Now let's go back here. See, the critical region is that region in the sample space in which if the calculated value lies, we reject the null hypothesis. Okay, fine. Now, suppose you are looking for renting an apartment. You listed all the available apartments from different real estate websites. You have a budget of 15,000 with you. Okay, you cannot spend more than that. The list of the apartments you have made are pricing from 7,000 to 30,000. Okay, select the random. Okay, null is saying you will rent an apartment and your budget is 15,000. Fine. Alternate will say obviously the opposite. You won't rent the apartment. So since your budget is 15K, you have to reject all the apartments above the price. Okay. So here the price is greater than 15K becomes your critical region. Agree? So the range is from 7K to 30K. And your budget is over here 15K. That means any price which is greater than this area, here that will reject the null hypothesis because null hypothesis is saying I will rent, but in this area I cannot afford, I cannot rent. So I will reject the null hypothesis. That means this area is also called critical region. Okay. So you have to reject that. Okay. In this scenario, that means all the prices greater than 15,000 becomes your critical region. Okay. The prices greater than this area, all this area will become your critical region. Okay. Critical region. Okay. The critical region lies in one tail or two tail on the probability distribution curve according to the alternate hypothesis. Okay. Critical region is predefined area corresponding to cutoff value in the probability. Okay. This we are going to see with an example. You will have better understanding. Okay. No worries. Fine. Okay. Okay. So this we are going to see. Okay. Fine. Excellent. Okay. Perfect. So we will cover this. Fine. So now, so actually today we are going to extend the class a bit, guys. Okay. So I hope that's fine for you with everybody.
Yes, sir.
Okay. Fine. So just to give a recap till now. So we understood basic sense of what is hypothesis testing, what is null hypothesis, what is alternate, how you can formulate. Both of that should be contradictory to each other. Okay, you can accept only one in both of these. Okay, and okay, and there is one important thing is failing to reject does not always mean that null is true. That means you did not have sufficient evidence at that point of time. Okay, fine. But fundamentally, just remember this: if you're accepting null, you are rejecting alternate. If you're rejecting null, you're accepting the alternate. Okay, fine. So now, see guys, now then what we have understood. So we understood one tail and two tail test. One tail, two tail. What is that we are going to see? Okay, but main thing is critical region is a region where you can reject the null hypothesis. Okay, fine. So now see here, we'll see an example. Okay, now coming to this example, what it is saying, actually shall I take the example or you want 2 minutes break, guys? Is it fine? Okay, shall I continue?
Yes, sir.
Okay, fine. Karthik, you there?
Yes, Santosh.
Okay, fine. So see, let's try to understand. This example will give you better understanding. See, to perform any test, guys, there are actually some fundamental rules. Okay, so we'll try to See that. See, first thing is, see, we'll go these steps involved hypothesis step by step. Okay, and we'll see few examples so that it will be very clear to you. Okay, whatever we have studied till now. First and foremost thing, fundamentally, what you need to do for any hypothesis testing, you need to do two things. One is what is null hypothesis and what is alternate hypothesis. You need to formulate. Okay, what is null, what is alternate. Okay, after that, you need to decide for a level of significance. Okay, you remember alpha, that alpha you need to decide. Okay, alpha you need to decide. Okay, and after that, alpha is nothing but it will say the probability of, see, alpha, what does actually mean is the probability of rejecting null hypothesis when it is actually true. Okay, see, don't get confused. See, alpha is the probability of rejecting null hypothesis when it's actually true. Okay, see guys, try to understand here. So try to understand here. Okay, see, actually guys, take 2 minutes break, guys, because we need to discuss a few more things. Okay, it will be again sort of too much. Okay, so take 2 to 3 minutes break. Okay, so then we'll come back and we'll see these steps and we'll see some examples so that at the end of this class you will have a very good understanding of hypothesis testing. Okay, so I'm just pause. Okay, fine. So let's focus back. See, for any hypothesis, okay, first thing is obviously, as we understood, null and alternate should be formulated. That's fine. After that, you need to have something called as level of significance, guys. That is alpha. Alpha is what? See, it is the probability of rejecting null hypothesis when it is actually true. What does that mean? What does it mean? Mean is, see guys, so when I just go over here, okay, so when I go here, try to understand that. See what we are doing. We are having some null and we are having some alternate. Okay, so we are doing some test and we are accepting this, rejecting this, that's fine. But if my test is not perfect, or if I don't have some sufficient amount of data, so I might be wrong. Okay, so for example, if null is actually true, actually null is true, actually it is true. Okay, actually it is true. Okay, but according to my test, I have rejected it. I rejected. That is possible. Okay, and it is also possible actually it is false, but there is some mistake in my test, but I accepted it. Getting guys? So it's actually true. Whatever it is saying, it is true. But my test, I have used some wrong formula, or my data is different, or my sample is not enough due to some reason. I'm not able to accept it, so I have rejected it. Okay, this is type of mistake I can do. Getting, and also actually it is false, but due to some reason I have accepted it. This is also false. Did you get this? We'll go step by step. Did you understand this point?
Yes, Santosh.
Okay, both are always wrong. Ante kada. See, actual ఉన్నదాన్ని రిజెక్ట్ చేసిన తప్పే, రాంగ్ ఉన్నదాన్ని యాక్సెప్ట్ చేసిన తప్పే. Okay, we will come to this after some time in much detail. This will be a very interesting example, but understand this. So in this scenario, alpha is the probability of rejecting null hypothesis when it is actually true. Okay, that means when null hypothesis is actually true, but if you reject it, అది wrong కదా. Null hypothesis is true. If it is true, you should accept it, but due to some reason you are rejecting it. That is wrong. So alpha will say what is the probability of rejecting null hypothesis when it is actually true. That means when null hypothesis is actually true, but you have rejected, what is that probability? Okay, that means in other words, I can also do mistake. That mistake probability I am giving it as 5%, 1%. Okay, so I'm not saying 100%, but 100% my test is perfect, but there might be some okay, drawbacks or some unknown mistakes, or okay, some flaws, that I'm adding 5% or 1%. Okay, you can take any measurement. Usually they'll take 5%. Okay, what is this 5%? It is saying that is a probability of rejecting null hypothesis. That means my test can reject null hypothesis even though it is true, but it is very small chance, 5%, okay, 0.05% of the time it is possible that I might reject null even though it is true. Okay, are we good with alpha? Or any confusion, let me know, because in hypothesis testing, right, so don't keep any doubts with you, just put them out and get those clarified. Okay, alpha clear?
Yeah, sir. But we have to consider 5% or 1%, sir. Exactly.
No, usually they'll take 5%. See, it depends. It depends. So if you're very confident about your test, okay, then you can take 1%. That means what? You're only 1%. You're saying, hey, there is only 1% of probability that I am going to reject the null hypothesis when it is true. What is this? This is actually a mistake. So in simple words, rejecting null hypothesis when it is true is what? It is a mistake.
Yes.
Mistake or not, right? Because null hypothesis is true, you should accept it, but you are rejecting here. So you're doing a mistake. Okay, but how much percentage you are assigning to that mistake? So whatever the test you are performing, okay, or correlation test or any sort of test, if you are very sure about that, you can take only 1%. You can say, hey, I'm only 1%. Okay, only 1%. I might be wrong, but 99% I am pretty sure that I am going to, if it is true, I will reject. So if it is true, I will accept. If it is false, I will reject. Okay. Actual scenario is what? Actual scenario is if it is true, I should what? I should accept this. Agree? I should accept this. Ideally. And if it is false, I should reject this. Actually, ideally, right? But the probability, the mistakes probability is if it is true, you are rejecting, or if it is false, you are accepting. That is wrong. Okay, and what is the probability you are based upon your test? Okay, if you're confident about your test, okay, so you can give only 1%, but usually they'll give 5%. Okay, but if you ask for one value, I will say 5%. Okay, just take 5% that you are already telling that okay, there are 5% of the chance that I might reject null hypothesis even though it is true. Okay, fine. After that, what we are going to do? Okay, once you do that, so then you will decide the test. Okay, what type of test you want to perform. Okay, what type of the test you want to perform based upon the data. Okay, so if it is a Z test or T test or whatever of test you want to do, you will do. Okay, then from that test you will get something called as test statistic, guys. Okay, these are just the steps we are going to see with the example. It will be very clear, don't worry. Okay, so but the steps are, first, third step is you need to do some test. From the test, what you will get some output that is called test statistic. Okay, and from the distribution you'll also get something called as critical value. Okay, and from that critical value you will construct something called as rejection region. You will construct what? Rejection region. That means what? As I've just told you, critical region is that region where you can reject null hypothesis. Okay, critical region is that region where you can reject null hypothesis. So from the distribution you will also see what is the rejection region. That means in which region I can reject the null hypothesis. That is called critical. Okay, based upon the critical value. And you will compare the test statistic and critical value. Okay, and if your test statistics is whatever the value you are getting, if that is falling in the rejection region, okay, if it is falling in the rejection region, that means you will reject the null hypothesis. If it is not, then you will accept. See here, if the critical value lies in the rejection region, okay, if the critical value lies in the rejection region, then we will reject the null hypothesis. Okay, the sample data provides sufficient evidence against null hypothesis, but if the critical region lies in the non-rejection region, we will not reject. Okay, fine. See, you got the test statistic, you got the critical region, and compare the test statistic with the critical region. Okay, and locate the position of the calculated test statistics that is in the rejection region or not. Okay, so see, if the critical region lies in the rejection region, reject the null hypothesis. If it is not, don't reject. Okay, so these points might be confusing when you study, but just don't care about that. I will give you with the example, you'll understand much better. Okay, but let's go for an example, guys. Too much of theory will bore me. Okay, see, okay, see, guys, this is interesting. Now, what is happening here? Where is this? Yeah, see, suppose a company is evaluating the impact of a new training program on a productivity of its employees. The company has data on the average productivity of its employees, okay, before implementing the training program. The average productivity is 50 units per day with a known population standard deviation of 5 units. After implementing the training program, the company measures the productivity of a random sample of 30. The sale has average productivity 53. The company wants to know if the new training is increased. Okay, see, fundamentally what it is saying is, there is a company, let's say a new company, after let's say you got a job, okay, so it's a MNC company, fine. So what is happening, it is evaluating the impact of the new training. So they are planning to conduct a new training program, okay. So they thought the employees are not performing well, so they want to give some training, okay. They have created a new training program on the productivity to increase the productivity, okay. So the company has a data on the average productivity of the employees before implementing the program, okay. Before they started to implement the training program, they have some statistics. What is that? The average productivity is 50 units per day. 50 units means you can take 50 hours, 50 minutes, some units, okay. How they're calculating, we don't want to worry, okay. But before, that means before the training, what was the scenario? Average is 50, okay. That means mean is 50, okay. And with a standard deviation of 5. That means what? Why we are giving standard deviation? You remember? That means it could be 50 plus or minus 5. Average is 50, but there might be some ups and downs. That means it could be 45 to 55, okay. From 45 to 55, everything will be covered, but with an average of 50, okay. Standard deviation. Now, once this is done, this is before the training, okay. This is before the training. Now, after giving the training, okay, after implementing the training program, the company measures the productivity of the random sample of 30 members, okay. So productivity training is done, okay. They have given the training to every employee, agree. And what they have done, they have took a sample of 30 members, okay. What is after? Okay, this is after training program. Here n is sample, number of samples is 30, okay. Now what happened? The sample has an average productivity of 53. Now the sample mean, see, I'm not writing mu. This is sample mean is 53. Okay, is 53. That means earlier it was 50 for the whole population. Okay, and standard deviation is 5. That's fine. But after giving the training, what happened? They took a sample of 30 and they have checked the average is 53. Okay. Now they want to know whether the new training has significantly increased productivity or not. Okay. Whether this new program has actually shown some positive effect or not. Okay. So here, one thing you need to understand here is, before the program, they have considered the complete population. Agree? 50 units per day with a known population. That means overall population they have considered, and 50 units per day. That means the mean is 50 before the program. But after the program, are they considering the whole population? Or just a sample?
Just sample.
Sample, right. That is the reason you need to perform some test, because after the sample, after the program also, if they give complete population details, then there is no point of this test, because before you are saying for 1000 people, the mean is 50. And after the training for the same 1000 people, if the mean is 53, it clearly means that the program has given positive results. From 50 it gained to 53. Agree? Because for the whole 1000 people we are checking, if you have the data for the whole 1000 people, before 50, after 53, clearly positive. But after the program, if it is 48, clearly negative. You don't need to, you don't need to do any other test, because for the whole population you are getting the complete measurements. Getting, guys?
Yes, sir.
Right? But here that's not the case. Earlier it was for whole population. Whole population it was 50. But after the training, they took a small sample. Okay. They took a small sample, right? So, and the sample size of 30, and that sample is having 53. Okay. Now we need to test whether if a particular sample is having 53, does that mean the program has actually created any positive effect? That means whether this sample is a perfect representation of the whole population. Okay, if this sample is having 53, does that mean it is having a decent what effect on the overall population or not? Okay, is the example clear? I mean the question clear? Everybody? Karthik, is the question clear, man? Just a second. Okay, fine. So we are saying, so what is saying? Yes, Santosh, mic issue. Oh, okay, Karthik. Okay, so before it was 50, and after that we are taking just a sample. Fine. So this is a point. Now see, we need to convert this into statistical statement. What he's saying, company wants to know if the new training has provided any significant increase in the productivity or not. Okay. So what it is saying, when we can decide that it has provided a significant increase, guys, if the average is 50, that means if the average is 50, okay, initially it is 50. If I want to say the program has significant increase, it has created some positive effect, what should be the value of this value? What should this become?
Greater than 50.
Perfect. It should be greater than 50. Super. Okay. So now we will start creating the things. Okay. First thing is null is saying, as I said, null. You remember anything which wherever you will have something equating, you can create it as a null hypothesis. Okay. So where was that? Thumb rule is any statement containing equality can be given as a null hypothesis. Okay. So here also initially null is saying null hypothesis. See, H naught is null hypothesis, guys. Are you familiar by now? So H naught is null hypothesis. Okay. So it is, this guy is saying, sorry. Okay. This guy is saying, hey, mean equal to 50. Okay. But alternate guy is saying mean is greater than 50. We want to prove only this. Okay. See how I have formulated the null and hypothesis. Try to understand here. If null is saying, okay, if null is saying mean equal to 50, alternate can say less than 50, it can say greater than 50, or it can say not equal to 50. Contradictory, right? It can contradict this guy. Less than 50 also, greater than 50 also, not equal to 50 also. Okay. But why did I choose greater than 50? You getting? Because if I choose less than 50, and if it is, I don't know, I'm not interested in less than 50, because less than 50 means the training is not having any, it is not increasing any productivity. Correct? It is actually decreasing the productivity if the new result is less than 50. So I don't want this guy. If it is equal to 50, sorry, if it is not equal to 50, that can be actually greater than 50 or less than 50. I'm not sure. Getting? If I prove this, okay, the actual new value is not equal to 50, but what does that mean? Whether it is greater than 50 or less than 50. If it is actually less than 50, then again I am falling into this scenario. Fine. I don't want this or don't want this. I'll have only this. So I will say if alternate is greater than 50, okay. So if alternate is greater than 50, so if I reject null, I will automatically accept the alternate. Okay. I'll automatically accept the alternate. Guys, are you getting? See. if I see, how can I tell you? See guys, this is important actually. The way how we are formulating the null and alternate is actually important. Okay, that should be according to your problem statement. See, I'm having this is why we took this way. We'll understand. See, if null is 50, I can take alternate is less than 50. For example, if I take alternate is mu is less than 50. Now what happens, guys? One of these should be true. Okay, one of these should be true. If I accept null hypothesis, that means what? Mu is 50. If I reject null hypothesis, mu is less than 50. That if I reject this guy, I'm accepting this guy. That means like mu is less than 50. Okay, but I am not interested in less than 50 because I want to see the program has increased the productivity. That means the value should be greater than 50. Getting? That is the reason I am formulating the null hypothesis alternate in such a way. Okay, I am formulating it in such a way that if at all I reject one, the other one will be in my favor. That means if I accept this, okay, that's fine. See, if I accept this guy, see, try to understand. If I accept this guy, okay, null is 50. That means the program is not having any effect. Okay, but if I reject this guy, that means what? I'm accepting this guy. That means obviously it is having a significant increase. Because the question he has asked is whether he just asked me whether it has significantly increased the productivity. He did not ask me whether it has decreased. Getting? If he asks me whether it has decreased, I will take it as 50, less than 50. Okay. If you ask me whether it is increased, I will take greater than 50. If you ask me, just check what happened, whether it has increased or decreased, I will say it is not equal to 50. Getting, guys?
Yes, Santosh.
I'll repeat this once again. See, he in the question he asked me, hey Santosh, just check whether it has increased the productivity. So I will test only that. That's why I took mean equal to 50. I took an alternate. I took greater than 50. Because if I reject this, I'll accept this. That means it has. I will say, hey, mean is greater than 50. That means yes, it has significantly improved. But if I'm not able to do this, I'll accept this. I'll say, hey, no, it is still 50. Okay, that is my goal. That's it. Whether it is increased or not. Null is saying there is no. Null is saying it is just 50. What is null saying? Even after training also mean is 50. That's what null is saying. I want to check for greater than 50. That's why I will take alternate as greater than 50. That means if I reject this, automatically I will get this. But if this guy has asked me instead of increased, if he asking decreased, then I will take less than 50. Okay, and I will do the test. And if I reject this, I will accept this. Less than 50 will be accepted. I will say, hey, actually there is chances that the training has decreased the productivity. Okay, but instead of asking decrease or increase, he will just say, hey, check what has happened. What is the effect? Just effect. I don't know whether it is positive or negative. Just check the effect. Then I will consider not equal to 50. Okay, I will consider not equal to 50. In that scenario, you need to do both. That means less than and greater than you need to consider. That will become two-tail test. Getting? If it is less than 50, it is one tail. That means only one thing you need to prove. If it is greater than 50, it is again one tail. Or either one tail, it is fine. But if it is not equal to, if it is just you want to check what is the change, whether it is positive or negative, it could be negative or it could be positive. That will become two tail test. Is that clear?
Yes, sir.
Oh, great, everybody. Cool. See, the same thing is happening over here. So here also he's saying, see, in this region, okay, wait, we'll come back again. This might confusing for the diagram. Okay, fine. So now let's just erase this. You guys really understood, right? Just don't simply say for my sake you understood. If you really understand, only tell me you understood. Okay, fine. So now our scenario is to just check increase. So that's why I took mu is greater than 50. Okay, alternate is 50, greater than 50. That's fine. So what we did, the first step to formulate the null hypothesis is done. Okay. After that, okay. So just give me a second. Okay. So Next thing is formulating null and alternate hypothesis done. Second thing is significance level. Okay, second thing is significance level. What is significance level? This is first step. Second step is significance level is alpha. Okay, alpha is usually I'll take it as 0.05 or 5%. Okay, fine. Third step is okay. See what was the third step? We'll go back.
Test.
Hmm?
Testing, sir.
No, before that. Yeah, so set up the, it is done, decide a level of is done. Okay, and choose the type of test you want to do as per the data. Okay, see, as per the data means what? Now what is our data? That is the reason you need to be careful that indirectly he's saying the sample is 30. That means if the greater sample is 30, our distribution, if the sample is 30, our distribution will be a normal distribution. You can use Z test. Getting? But if the sample is less than 30, then what happens, guys? Can someone answer? If you're not able to collect enough samples, if the sample is less than 30, what type of distribution it will become?
Yeah.
Huh?
T-test.
Yes, it will become t-test. Good solution. So, see, sample is less than 30. Oh, whenever the samples n is less than 30, you will have t-test. As the sample is increasing, it will become the normal distribution. Okay, fine. So, but here our samples are 30. Now our distribution will be a normal distribution and we can use a Z test. Okay. And if you're using the Z test, then you need to use the Z statistic. You need to use the Z statistic. What is Z statistic? Okay. See what he's saying. Decide the test and calculate the test statistic. Z score, T score using the formula. What is the Z test? Z test is Z value. What is Z value? X bar minus mu by sigma. And but here, if you remember, our sample standard deviation will be n. Okay, because if the population standard deviation equal to rho, our sample standard deviation will be rho by square root of n. Now, if you put these values, what is the x bar? X bar is 53. Okay, because they did not give us they did not give us the what I say, the sample standard deviation. So if the population standard deviation equal to 5, okay, if you're taking sufficient, like if the samples are greater than 30, okay, so then your sample standard deviation, you can take it as rho by square root of n. N is number of samples. Okay, minus what is mu, guys?
Sir, once explain why we consider root n.
No, see, if the standard population standard deviation equal to rho, okay, the sample standard deviation will be rho by square root of n from the central limit theorem.
Yes, sir. Yes, sir. Got it.
Okay, if I go back. Yeah, see here, if it is rho, our will be rho by square root of n. Okay.
Okay, sir.
Right. So here also, when that will be possible? So when you have a random sample of 30, that means if it is greater than or equal to 30, if it is less than 30, then it will become t distribution. Then it will not be directly equal. Okay. But here, since our samples, you have enough number of samples, you can take it as normal distribution. And if the population, they give population standard deviation equal to 5, which will give us sample standard deviation is rho by square root of n. Is that clear? Okay. So x bar is 50. What is mu?
50.
50 by rho is 5 by square root of 30. How much this will be, guys? 3 by 5 by square root of 30. Can someone calculate? Yeah. So 3 by 5 into square root of 30 is 3.28. Can you see here? So it is 3.28. Okay. 3.28. Fine. So now if you see here, is this clear? T statistic is clear? No? See guys. Z, sorry, not T, Z statistic, okay? Z, see, first you have to do the alpha and then you have Z statistic. Z statistic value is what? X minus mu by rho, and for sample it will be X bar minus mu by rho by n. You put the values, you got 3.28. Are we good?
Yes, sir.
Okay, cool. So next thing is you need to create the rejection region. Okay. So obtain the critical value and construct the rejection region. So this is important. See, now what we are going to do over here is, so now since it is a normal distribution, okay, assume it's a normal distribution. Over here, what is our critical region? What is the alpha you are giving? Alpha is 0.05. Okay, alpha is 0.05. Okay, so this alpha you need to plot it over here. That means what? The rejection, wherever you are having the 0.05 area, right? So okay, this area, okay. So if you consider this as 0.05, the remaining will be 0.95. Okay, 0.05, the remaining will be 0.95. Okay, why we are taking? Because alpha we have taken it as 0.05. That means the region where you might reject the null hypothesis, okay, where you have rejected the null hypothesis, even though it is true, okay, that you have considered as alpha. Okay, so now alpha is 0.05, then you need to find out in the district, in the graph, where you are having the area is will be equal to 0.05. Okay, and the remaining area will be what? Remaining area will be 0.95. Okay, okay. Now this, in this scenario, the level of significance alpha, okay, this will be the critical region, guys. This will be the critical region. Okay, why this will be the critical region? Because in statistics there is one important thing you need to remember over here is, okay, because actually this took a lot of time for me to also get to this point. The point over here is, where whatever, whether you say significance level, that is same as alpha, that is same as critical region. Okay, this is very, very important, guys. Okay, so I'll highlight significance level or alpha or critical region, whatever we are saying, right, that all actually point to the same thing. So what is happening over here, when I'm saying alpha when I'm saying alpha equals 0.05, okay, so that 0.05 area wherever you are having, right, so that will be the critical region. Okay, that will be the critical region or the rejection region. Okay, the alpha value, okay, critical value is 0.05. Okay, alpha is what significant. The words might be confusing, guys. Don't worry, because they we use different terminology. So it's called level of significance, significance level, or alpha, or critical region. So what does that mean is, first, alpha is the level of significance, it is 0.05. Okay, so that means 0.05 area is this one. Okay, fine. So this region is also called as critical region, or it's called as rejection region. Okay, it's also called as rejection region. Okay, so now the point here is, you need to calculate which value. Okay, this is it, which value. Okay, which value is giving us 0.95 area. If this is 0.05, alpha is 0.05, this becomes 0.05. Overall is what? Overall area is 1. 1 minus 0.05 is how much? 0.95. This whole thing is 0.95.
Yes.
So we want to know which particular point. Okay, which point is giving us this area. Why? Because if you remember from the cumulative distribution, when I'm saying z is less than or equal to, that means what? See, whatever, see, for example, if this value is, I don't know, 0.8, okay, that what it will give, it will give this will give the area less than or equal to this. If I say z value is less than or equal to 0.8, that means it will consider a complete area less than this. We are seeing this from many classes, you remember?
Santosh.
Okay, so now yeah, so now we understood that alpha is 0.05 and the area is 0.95. So we want to find out which particular value is giving the is giving this 0.095 area. So further, what we need to do, we need to go to the Z table. Okay, and what was the area? 0.95. Fine. Where you will have the 0.95? Yeah, 0.95. Okay, and what is the value? It is 1.6 plus 0.5. Okay, 1.6 plus 0.5. Okay, it is 1.6 plus 0.5. It is 1.65. Fine. This value is 1.65, guys. 1.65. This value is 1.65. Why? Because according to the graph, whatever the value you take, okay, see, 1.65 means 1.65 value will cover 95% of the area. So if you take 1.65, that means wherever you are having 1.65, all the area less than or equal to 1.65, less than or equal to 1.65 will cover 95% of the area. Okay, so now anything greater than 1.65 will fall where? Here in this region. Okay.
Yes.
Okay, guys, are you there with me, guys? I really want to know. See, I can explain it again. Don't worry, but just tell me.
Not understand, sir.
Not understand. Okay, good. That you should say. Okay. See, will come again. Okay, very simple. We'll start from first. Simple. Okay, where you did not understand, just stop me. Formulate null and alternate. Clear?
Yes, sir.
Alpha value decide 5%. Clear?
Yes, sir.
Our number of samples is 30. So we will assume that it is normal distribution. Because it is normal distribution, we can consider Z test and we will use a Z static. Z statistic value is x minus mu by rho, but here it will be x minus mu by rho by square root of n. Put the values, you got some value. This is Z statistic. Put that aside. Put that aside. Z statistic from the test, you are saying it is 3.28. That keep it aside. Clear?
Yes, sir.
Everybody? Meghana?
Yes, sir.
Okay, fine. After that, that is test, guys. This is Z statistic is what this is from the whatever the given values they are given. So this is the value which we got. That is fine. But coming to our distribution, we need to calculate a rejection region or a critical region. Okay, that how we are going to do our normal distribution, because of the alpha is what, where we can go wrong. Okay, where we can go wrong, that region is this one. Okay, from the overall distribution, that region is 0.05. So where you are having 0.05, this area will be 0.05. Some area I'm taking, but if some part of the area is 0.05, which is the alpha, the other area will be 0.95, obviously, because the overall area will be 1. Okay, now I want to calculate which particular value is giving me this 95% area. Okay, this whole area is 95, means what is that value? Because this value, if it is 1.65, that means all the values, okay, z less than or equal to 1.65 will give the 95% area. Okay, you're getting this? If I have a value of, let's say, 0.2, that means what? The area you calculated will be less than or equal to 0.2. The area you calculate will be less than or equal to 0.2. The area you will be less than or equal to 0.2. Okay, less than or all the values you take over here from the Z table, whatever you see, those will be what? Those will be less than or equal to that value. Let's wait a minute. I think Meghna dropped. Any power issue?
Yes, sir. She messaged me network issue.
What? Network issue?
Yes, sir.
Okay, fine. So if you see here, it is having 0. If it is 0.05, okay, if it is 0.05, the remaining part will be 0.95. Okay, so what does that mean? This particular value, if you check from the table, wherever you're having 0.95, okay, this is having 0.95, that means it's 1.605. Okay, so this value is 1.65. This value is 1.65. This value, which is giving us 0.95% of area, is 1.65. Okay, so now 1.65 till 1.65, we are having 95% area, but above that, whatever you are having is the rejection region, because this is falling in the, this is where we are having the alpha is where you are having the rejection region. Agree?
Yes, Santosh.
Now if you see the test statistic 3.28, if this is 1.65, where the 3.28 will be, guys? If it is 1.65, here somewhere you will have some 2, and somewhere you will have some 3, and somewhere you will have some 3.8. So obviously it is falling in the rejection region.
But why we are taking 0.05 only in that area? We can take it anywhere, right? That's the
Correct. But what we want to check, it is greater than 50, right? So greater than will be this side. If it is less than 50, you will take this area.
okay.
Okay. So if it is greater than 50, you will take this side. If it is less than 50, you will take this area.
Okay.
Okay. So yeah, that's a good question. So now, since this value is 3.28, so obviously it will fall. It will be, this 3.28 is greater than our critical value. What is our critical value? Our critical value is 1.65, and our test statistic is
3.2.
3.28. So obviously our test statistic is greater than critical value. Okay, that means it is falling in the rejection region. Agree?
Yes.
It is falling in the rejection region. So that means what? You can reject the null hypothesis. Okay, so you are rejecting the null hypothesis. Agree? So because our value or whatever the test statistic, whatever we are getting, okay, so that is falling in the rejection region. Whatever all this is, that is falling in the rejection region. Okay, so because it is falling over there, you can reject the null hypothesis, because it is rejection region. You will what we'll do, you will come over here and what finally we will reject the null hypothesis and we will accept the alternate. That means what? Alternate is saying the new value is greater than 50. That means yes, the test has actually significantly improved the productivity. That we will accept. Okay. Why? Because we are able to reject the null. Whatever we are doing, everything is what? Whether it is just focusing on null, whether we can accept null or whether we can reject null. Okay. So because we are rejecting it, we will, because we are rejecting what? Rejecting the null hypothesis. Okay.
Yeah.
Fine. So since you're rejecting the null hypothesis, you need to accept the alternate hypothesis and say, hey, okay, my sir, is it necessary? Seriously saying, sir, is it necessary to take alpha as 5% or 1% every problem? Significant will not differ. See, Sirisha, you can take. See, you can take any value, Sirisha, but generally from lot of test what we have done, so we take it as alpha as 5, but you can take any value. Okay, you can take any value of this. What happens if you take larger value? If you take alpha is having let's say alpha value is more, that means as Sirisha is saying, but before we'll come to that, okay, but till this example, are we good? So test statistic is falling in the rejection region, so obviously we are rejecting null hypothesis and stating, hey, whatever you are saying that program is not having any effect, that is wrong, because clearly program is having some effect. Is that clear?
Yes.
Okay. Now, yeah, Sirisha, what you're saying? Okay, sir, but alpha is 5 in every scenario. The Z is 1.65 only. No, sir. Yeah, that's a very good point, Sirisha. Yeah, perfect. Correct. So usually, because if at all the distribution is normal distribution, correct, Sirisha, you are on track. So if the distribution is normal distribution, then you will consider it as this, and the alpha is always 0.05. Correct. But if the distribution is different, then you will go for the t statistic. And if the distribution is some other test, you will go for some other test. Like you have other test also, Sirisha. You will have chi-square test, you have Samanova, you have Z test, which we will see. But if it is a normal distribution, then alpha you can take it as 0.05. Okay. But let's say if alpha is you're taking okay, you're taking what? A big alpha. Okay, that means 10% alpha you're taking. Okay, that means what? It will cover 10% of the area. That means what? That means what? It will cover till here. Okay, if you cover till here, okay, this value will be less or small than this?
Small.
Small, correct? So this will be some, I'm guessing it is 1.4, for example. Okay. Earlier, if it is 1.65, anything greater than 1.65, you are rejecting. Correct? Anything greater than 6.5, it is falling in the rejection region, you are rejecting. That
Yes,
means
sir.
if this test statistic, if it is just 1.7 also, we will reject. But now if you take alpha as 10, then you need to cover 10% of the area, and that means it will come bit closer over here. It is 1.4. Now in this scenario, anything greater than 1.4 you will reject. Okay, anything greater than 1.4 you will reject. That means what? You are having more values for the rejection. Okay, for example, here if there is some value 1.5, okay, earlier you will not reject that because it is not falling in this region, but now you will reject that because it is falling in this region. That means more and more values you are able to, you will reject. Are you getting, Sirisha?
Yes.
That means what? Indirectly your test is not perfect. Are you getting? If you're rejecting for more and more values, your test is not perfect. If your test is perfect, you should have less values to reject. What is this rejection? Rejection is What is this alpha? Alpha is the probability of rejecting null hypothesis when it is actually true. Okay, or the critical region where you can reject the null hypothesis. Okay, so if you're increasing the alpha, for example, here you will put, okay, 50% we are putting, okay, this 50% is your alpha. Okay, 50% is your alpha. So what will be this value, guys? What will be this value? If I go over here and see 50, 0.50, 0.0, okay, 0.0 is a 50. Okay, so 0.0, this is 0. Okay, and anything greater, sir, correlation concept will not be used in it or not? No, why correlation will come in middle of this? No, correlation is different. Correlation is different, Srisha. So if you're taking larger values of alpha, you will have larger areas. Okay, you will have larger areas. Okay, and you will have more values to reject the null hypothesis. Okay, you will have more values to reject the null hypothesis. Okay, so that's why, and that is not what we want, right? So actually what we want to see in the rejection region. Okay, in the rejection, wherever you are having this rejection region where you are rejecting null hypothesis, and what was happening, so what the probability of rejecting null hypothesis when it is actually true, okay, that we don't want. We want to actually fairly accept the null hypothesis or fairly reject the null hypothesis. We don't want to do this mistake of this alpha. What is alpha? Probability of rejecting null hypothesis when it is actually true. We don't want to do that. Okay, so that's why usually we put it as 5%, just saying that, okay, 5% of chance it can be that it can be rejected. Okay, fine. So then you will take it as 1.65. Okay, so as you said, for any normal distribution example, if you consider, it will be 1.65, and the test statistic, if it is greater than 1.65, it will be rejected. If it is less than 1.65, you can accept it. Okay, but if you take 1%, so obviously it will be somewhere over here. Okay, somewhere over here you will have this small area. You will have small area of rejection. Okay, you will have small area of rejection. That means most of the time you are confident. Most of the times you are confident that you can accept the null hypothesis, but there will be some small area where you can reject the null hypothesis. Okay.
Yes, sir.
Okay. Fine, guys. I would say let me stop over here because too much if we continue. Okay. So fine, guys. Tomorrow we'll see one more example. Okay. But just I would say, since we discussed a lot of concepts, just go through the class once again. Okay. And start making notes. Okay, and just ping me wherever you not understand. Fine. So I hope the example is clear. So test statistic, and the test statistic is falling in the rejection region, will reject. Okay. Just to conclude. So if you're saying, if the critical region lies in the rejection region, okay, we will reject the hypothesis. Okay, and if the critical region lies in non-rejection area, okay, we will not reject. Okay, so whatever the value, this is a rejection region, and if this is falling over here, we will reject. If it is falling outside this, we will not reject. Okay, so fine. That's all for today, I would say, and we can connect tomorrow, and we'll try to continue the concept. Okay.
Sure, sir.
Okay. Thanks, guys. Take care.